Hello, everyone. How are you guys doing today? Good, bad? No comments, tired? So we have exactly 21 weeks. That's it. 3. We have one exam. Our last in-class exam will be 2 weeks. In 2 weeks. And then our final exam will be in 3 weeks. Okay, and then you'll be done. I don't have your exam today. I'm going to give it to you tomorrow. And then I'm planning to show you a calculator where you can see how much you need to have in your homework, fifth exam, and final exam in order to pass the class or to get your desired grade. Okay. So I'll post it also on Brightspace so you can calculate your own, and I'll show you in class how to use that. And we are almost done with the syllabus. From chapter 10, we have 10.5, 6, 7. So 3 sections from chapter 10, and then 6 sections in chapter 11. 6 and 3, 9 sections. Yeah. 9 section, and we have how many classes? This week 3, next week 2, 5 classes. 5 classes, 9 section. I think we'll be able to do it. My point is to finish everything by the 5th exam, so that the last week will be only review. 2 classes for review, and the last class is the final exam. What suggestion you wanted to give me?
Can we focus on the 5th exam and the final and not do the other? I mean, if everybody agrees.
So usually in the final exam, there are no questions from 10.5, but I should still introduce you to the topic because it's division of division of thinking, radical. So you should at least know how to divide, okay? And if you know how to do this, then you can do 10.7, because 10.7 is the same division of radical, but instead of radical symbol, we use I. Okay? So there will be no question in the final exam from this section. Most likely they don't. I mean, mostly they don't give any question from this section, but it will be helpful for imaginary numbers. The extra topic, intermediate form. It's called intermediate form because when you divide radical, you don't get anything real. Okay, sometimes. The first thing is we actually don't know how to even divide radical. Okay, just like how to divide by 0, we have no idea. That's why it doesn't exist. Same thing, how to divide by radical, we have no idea how to divide by radical. So instead of dividing by radical, what we do is called rationalizing. It means do something so that there will be no radical symbol on the denominator. Or if you rationalize numerator, it means do something so that there will be no radical symbol on the numerator. Because we don't know how to divide. We know how to multiply, how to add, how to subtract, how to simplify. The only thing we don't know is how to divide. So we never divide, okay? We never divide by radical. Instead, we just do something called rationalizing. It means either get the radical symbol from the numerator or from the denominator. It depends on the direction. And why we do that? We do that because sometimes we have to find some division. For example, here we have square root of 9 plus 8 minus 3 divided by 8, and we want to know how much is the y value when h is 0 in this function. It's a function, okay? So in this function, how much is the y value when h is 0? Well, if you substitute h with 0, we have a problem. So when you substitute 0, we have square root of 9 plus 0 minus 3 divided by 0. See, you're dividing by 0, automatically that gives you something doesn't exist. So you have no idea what's the y value and the x value or the h value here is 0. But we want to get an idea, like if there exists some y value, what that number would be. We want to know, we want to estimate a y value. So since we can divide here, so to estimate the y value, we do rationalizing the numerator. What does that mean? It means do something so that there will be no radical symbol on the numerator. And then after you modify by rationalizing, whatever remains, that will tell us what the y value would be. Okay? So how do you rationalize? We want to do something so that there will be no radical symbol, right? So the only thing we can do here, we are not allowed to add something or subtract something. The only thing we're allowed to do is multiply by something. That reminds us of what? LCD, right? In LCD, we are not allowed to add or subtract anything, but we can only multiply by something to have the same denominator, right? Like for example, if we have 1/2 minus 1/3, we know the LCD is 6, right? So you cannot add 4 and cannot add 3, right? It doesn't make sense. We never do that. Instead, we multiply by 3 here and we multiply by 2 here, right? So there are some cases where only we are allowed to multiply. We are not allowed to add, subtract, or square. We cannot do anything except multiplication. So same scenario here. In order to get rid of that radical symbol, we want to multiply by something so that the radical symbol will vanish. In reality, if you have a square root, how can you erase the square root? What do you need? It's power, right? If you have a square root, you need square power. But you're not allowed to do squaring. So how can you have the square here? Twice, multiply by the same thing, it becomes twice. So if you have square root of 2, you need another square root of 2. So you have square root of 2 squared. There is no more radical. See? So that is our idea. Multiply by something so that you have the exact same 2 radical so that the square finishes the radical symbol. So how we are going to rationalize? That is our goal here. So depending on what we have, we rationalize differently. For example, here, we have square root of 3 over square root of 2. And the direction says rationalize the denominator. Means do something so that there will be no more square root on the denominator. 2 will be there without the square root. In other words, erase the thingy, square root. So the only thing you're allowed to do is multiply. What can you multiply the denominator by so that there will be only 2 instead of the square root of 2? Multiply by square root of 2. But math is fair, right? If you multiply the denominator, what do you have to do? Multiply the numerator. So the denominator, we have exact same thing twice. So basically we have square root of 2 squared. That's why the square root and square power cancel out. We have the 2 only. But now what happens in the numerator? The yellow. We have 3 plus and 2 plus. They both are positive numbers. And you have the same exact square root, right? So are you allowed to multiply their inside? What's the condition to multiply radical? They have to have exact same 2 things, exact same radical, right? And as long as their radicals are positive, we are allowed to multiply them. Do you remember from before exam? So if it's a negative number, first you have to pull out the negative and then you can multiply. But when you have positive from the beginning, you can simply multiply. So we get square root of 6. And we can simplify that. So instead of 3 here, we actually get square root of 6. And we are done. We actually didn't divide, but this is called division. Division of radical, which is called rationalizing. Is it clear, the idea? Main idea is erase your radical symbol. The only way you can erase is by multiplying by something. So depending on what radical symbol you have to multiply by that many thingy. And then all the power and radical symbol cancel out. And on the numerator, you simply multiply. If you can simplify later on, you simplify. If you cannot, leave it alone. Is anybody confused so far? Any question? No? Okay. Let's try this one. 7 divided by cube root of 7. Our goal is to do something so that there will be only 7 on the denominator, no cubic root. And 7 will be on the top. And the only thing you can do is multiply. So what can you multiply by so that the cube root of 7 will turn into only 7? What do you have to multiply by? Cube root of 7. But can you cancel the cube root? And in order to cancel the cube root, how many power do you have to have? 3 of them, right? So how many cube root of 7 you need to have? 1 more. Right? When you have 3 power, you have to see the exact same thing 3 times. If you have a 4th power, you need to see exact same thing 4 times. Only then the power and the radical become same. The cube root gets cube power if you multiply by extra twice. Clear? Now on the numerator, you don't have to write it twice. You can simply write cube root of 7 times 7, 49. Because you have to simplify them later anyway. You cannot just leave them this times that. So if you want, you can write cube root of 7 times cube root of 7, or if you want, you can simply write 49. It's up to you. So in the numerator, we have 7 times cube root of 49. On the denominator, the cube root, cube power cancel out, so no more cube. And we have cube root of 49. So you're done with rationalizing. Our goal was to get rid of the cube root. We got rid of the cube root, so we are done with rationalizing. But are we done with the math problem? No, why not? Cancel. See, we have a 7 on the top, 7 on the bottom. Anytime you can cancel anything, you must do so. That means our answer is simply cube root of 49. Who is lost? Anybody? Is it clear, guys? Everyone? Great. Then you try one more. 5th root this time. And let's say this is 4. Instead of 2, let's say this is 4. Oh man, I can't write here. Yeah. Can I get a pinch here? Well, what's wrong? divided by fifth root of 2. Okay, I can't write here. So ignore the left page, okay? I can't write anything here. Hmm. 4 divided by fifth root of 2. This is 5. And if you're done, there is one more question. Really? 2 more? Yeah. Okay, so let me write this down here. 7x over 45. Okay, these 3. 4 divided by fifth root of 2, 11 divided by square root of 2x, and square root of 7x over 45y. 5 in for 2 minutes, and then we'll do them together. The idea is that you multiply 4 times, so you get 12 and you get 16. I think we multiplied 1, 2, 3, 4 times extra. So it's 4 times extra. I'm starting to 16. So this one, and the denominator not to be one, we find we have the same. Fact to divide from two and then let's say them together. To the first one, we want exact same thing 5 times. Cube root of 2, fifth root of 5 times. That means we need fifth root of 2, fifth root of 2, fifth root of 2, fifth root of 2. Then we have 1, 2, 3, 4, 5 times the exact same thing. So we get 5 power. In other words, we added total 1, 2, 3, 4. 4 times. So that gives us 16. So we have 4 fifth root of 16. The fifth power and fifth root cancel out. We have 4 fifth root of 16, and denominator gets the 2 without any radical. But we cannot stop here because these are cancelable. So you divide 4 by 2, you get 2 on the numerator. So your final answer is 2 fifth root of 16, which you cannot combine. So you just leave them alone. The next one is the same thing. We want 2x twice on the denominator so that at the end we get 2x without any radical. So in order to do that, we need the same thing one more time. So total we have once and twice with the 2 power. So we just need to add one more extra denominator. And we multiply the numerator also. So on the numerator, we have 11 square root of 2x, which we cannot combine. So we leave them as they are, 11 square root of 2x. On the denominator, square root, square power cancel out. And then we actually got stuck. We have nothing to do. We cannot cancel these 2x on the denominator with the numerator because numerator is inside the radical. And we cannot also cancel 11 by 2. So we have to stop here. There is nothing we can do anymore. And then the last one, division. Well, the direction says rationalize the denominator. That means we need to see the denominator separately. So first step, we have 7x and 45y. And then you have two things to do. I mean, two ways you can do this. Either you multiply top and bottom by the denominator because you have to do the same thing twice. Or first, simplify the denominator. Can you simplify the denominator? Can you divide 45 by a perfect square number? 9. So we can. Anytime we can simplify anything, try to simplify fast because that will make your life easier. So it's 9 times 5. That means on the denominator, we have square root of 9 times square root of 5x. So not x, y, my bad. On the numerator, we have the same thing. And we cannot simplify the numerator. In other words, we have square root of 7x over 3 times square root of 5y. So this is the original equation. Rationalize the denominator of this version because this is simplified. That means we don't want, let's say from here to here, square root of 7x. 3 is outside of the radical, so it doesn't give us any problem. It's free, so ignore it. Our problem is lying here. This thing has a radical, so we want to have the radical symbol not there. So we want simply 5y here. So what can I do so that there will be only 5y on the denominator next to the 3? Multiply by 5y. So square root of 5y. That means on the numerator, we actually don't have 7x. We have 35xy. Because we can multiply these two. 7 times 5 is 35, x times y is xy. So we can rewrite our numerator. And denominator becomes rootless. So 15y. And the numerator is 35xy. Can you divide 35 by any perfect square number? 35 by 4, no. 35 by 9, no. 35 by 16, no. So 35 cannot be simplified anymore. If you didn't do that, but if you multiply top and bottom by square root of 40y, then you have to multiply again at the end. Because 45 is reducible. Anytime you have something reducible, you must reduce that. Either do it at the beginning or you have to do it at the end. Doing it at the beginning is actually simpler than doing it at the end. So all of these, you're going to see them in your homework and quiz on MyMathLab. And on the exam, I'll give you something like fifth power, cube power, something like those. The simpler ones, okay? So this is what we do when we have only one term on the denominator. Means denominator doesn't have any plus minus. Okay? But not always this will be the case, right? Sometimes you're going to have more than one term on the denominator. For example, what's wrong with this? Today my computer is very sensitive. I don't know why. Come on, come on, come on. It's not moving. Is it my hand or the computer? Where's my hand? My finger. So the denominator, see this denominator has two terms. One is square root of 5 and one is 1. And we cannot just multiply by square root of 5 here. If you multiply by square root of 5, we get if you multiply by square root of 5, you have to distribute. And when you distribute, you end up getting square root of 5 again. So multiplying by square root of 5 doesn't help us here. So we cannot use the same method anymore. That means we have to find a new method for this type of problem. And this new method is called using conjugate to rationalize. Conjugate means what? Exact same two terms, only the middle terms are different. And you already worked with many conjugates so far. A plus b has a conjugate a minus b. And when you multiply a plus b and a minus b, what do you get? Difference of perfect squares. When you have difference of perfect squares, automatically the 5 square root of 5 will get squared. So there will be no more radical. Same thing, x plus y is a conjugate x minus y. And when you multiply the two conjugates, you get difference of their squares. So there will be no more radical. So similarly, it doesn't matter what do you have on the denominator. All you have to do is write the exact same thing, but change their sign. So this denominator has square root of 5 plus 1. You just have to multiply by square root of 5 minus 1. Square root of 5 minus 1. If minus is given, it's multiplied by plus. So whatever sign is given, you multiply by the other sign. As a result, what happens? When you multiply the denominator, you get difference of their squares. So square root of 5 minus 1 square. 5 minus 1, that becomes 4. And when you have only one term given on the numerator, leave it alone. For one term given, leave the numerator alone. It means don't multiply. 5 square root of 5 minus 1. 5 square root of 5 minus 1. 5 square root of 5 minus 1. Why? Because sometimes there is a case where at the end, when you rationalize, you can cancel the numerator or the denominator. Here we cannot, but there are some cases where you can. That's why I leave it alone. When you have only one term on the numerator. But if you have two terms, you have to distribute. And that's all you have to do. So in the exam, I'm going to give you one of these. So from this section, there will be two questions. One is whatever we did with one denominator, and one is with two denominator, two terms of the denominator. So, man, I have to do this. Any questions so far? No. Now we are going to do the same thing, but this time we are rationalizing the numerator. Read the direction. It says rationalize the numerator and then substitute h with 5. For example, if you substitute at the beginning h with 5, on the denominator we have 5 minus 5, which is 0, and then it's undefined. So this is the scenario we talked about at the beginning of the class. We know when h value is 5, there is no y value. But we want to know what would be the y value if it existed, okay? We know it doesn't exist. But what if it does exist? We just don't know how much is it. So if it did exist, what that number would be? This is our goal to find out. So our goal is to modify this function by rationalizing. And since we are rationalizing the numerator, so the two terms we have on the numerator is this and this entire thing. These are the two terms we have on the numerator. And just like this, when you have two terms, we have to multiply numerator, denominator by the conjugate of whatever you are rationalizing. Since we are rationalizing the numerator, this time our conjugate is 3 plus square root of h plus 4. In conjugate, we change the symbol only once. It's not h minus 4. It has to be h plus 4, and only the minus in the between 3 and the radical, that will turn into plus. So we are changing only one symbol, only one sign, this sign. You cannot change symbol twice. You're only allowed to change symbol once. The 3 plus square root of h plus 4. Multiply numerator and denominator by the conjugate. Leave the denominator alone. Do not distribute. Leave it alone. But work on the numerator because your goal is to get rid of the radical symbol from the numerator. So since we have conjugate on the numerator, let me write the denominator first. 3 plus this. So what do you get from multiplying the numerators? They are two conjugates. So what do you get back? 3 square, okay, minus h plus 4 under the radical square. Because our second term is entire radical term, the radical thing. When you multiply two conjugates, you get the two term squares. What are the two terms we have? 3, so you get 3 square. And then the second term is square root of h plus 4. So you have to have square root of h plus 4 square.
Yeah, no, it's just whatever. The minus.
That's the symbol we have to have difference of perfect squares. Anytime you multiply two conjugates, it's difference of their squares. Never sum, always difference. So see, now the radical and the square and square root cancel out. And since you're subtracting, don't forget to change the sign inside. So it's 9 minus h plus 4 or 9 minus h minus 4. Actually, let me write that and then on the next line we're going to do it. H minus 5, 3 plus h plus 4. So we have 9 minus h minus 4, h minus 5, 3 plus h plus 4. We're subtracting this quantity. Anytime you subtract more than one term, the sign will change whatever you're subtracting. So what is our final result? What do you get in the numerator? 9 minus h minus 4. So what do you have? 9 and 4, they are like terms, right? So what is 9 minus 4? 5. So 5 minus h minus 5, 3 plus h plus 4. Are we done? No, we are not.
Can we cancel 5?
We can cancel 5 minus h with h minus 5. But are they exactly same two things? No. So what do you get back when you cancel them? -1. If you have no idea, no problem. You have 5 minus h over h minus 5. Replace h with 0. So you have 5 minus 0 over 0 minus 5, which is 5 over -5. What's the answer you get? -1. So anytime if you're not sure whether we can cancel them or not, always replace the variable with 0 and then see what you get. That means we have -1 on the top and then 3 plus square root of h plus 4 on the denominator. Now this is the rationalized form of the same function here. They look completely different, but they are exact same graph. But there is only one difference between them. When you replace h equals 5 here, what do you get? 0 on the denominator, right? Which is undefined. But now let's see when h is 5, what do you get back this time? -1, 3 plus square root of 5 plus 4, which is -1, 3 plus, what is 5 plus 4? 9. That means we have square root of 9 under the radical, which is 3. See, this time we do get a result. We do get a valid number. Even though they're exact same graph, but they have one difference. H equals 5 doesn't exist in this graph, but h equals 5 gives us a real number, -16, in that graph. So see, even though this graph doesn't have y value for h equals 5, but if it did have a y value, that y value would have been -16. So to find out what that y value would be, to figure that out, we did all these things. And then we realized, oh, for h equals 5, the y would be -16. It's not there, but if it was there, that would be the number, -16. Okay, so in our real life, we come up with, like sometimes we face some functions where we need to know the y value at a specific number, specific x value, but that doesn't exist. So in order to get the idea of what that number would be, the rationalizing is needed. So actually, we don't do it nowadays. Computer does everything for us. But we have to tell the computer, right? Like if you create a algorithm and then tell computer, use that algorithm to tell me the answer, you need to know what's going on inside. So even though this will not be in the exam, in the final exam, but still, if you ever do something with computer, like coding or anything, programming, you need to know this math. Okay? I hope you can remember till that time. Now, one last question, I think. Yep, one last question, an easy one. Rationalizing the numerator from your homework. It's the same concept from before. Your goal is to do something so that you have 2x to the 5 on the numerator instead of the radical symbol. Ready? We have two choices. Either simplify at the beginning or simplify at the end. Here we can simplify the x to the 5. Not 2, but x to the 5. How do I know I can simplify? Because the power inside cannot be bigger than your radical symbol. Anytime you have power bigger than radical symbol, you can simplify. So we have inside 5 power, but the outside you have a 3 radical. So we can simplify. So let's simplify first. Cube root of 2. Let's break down x to the 5. When you divide 5 by 3, how many times you can divide 5 by 3? 1. So you have 5 divided by 3 is 1. And how much is the remainder? 2. So you have x to the 5. So let me do this. Let's say you have cube root of 2 alone. And then you have cube root of x to the 5. So we can simplify this. This becomes, I cannot write. Really? What's wrong with this? Come on. Insert the page. Oh, I didn't get insert. But here. Come on, what's wrong with this? Okay, let me close it and turn back in. Well, see. Close. I can write. So x to the 5 is x cubed and x squared. So cube root of this, cube root of that, they cancel out. We get x and cube root of x squared. So 1 remainder 2. It means we have to get 1 power outside of the radical and 2 power inside the radical. This is what it means. 1 power outside, 2 power inside. So this thing, we have inside 2 and inside x squared. So they become x outside and cube root of 2x squared inside. So this is x times cube root of 2x squared over 9. If you simplify this first, this is what you get. And then you rationalize. So, to rationalize, we only need to multiply this, not the entire x to the 5. I'll show you both methods if this is confusing for you. So let me do it on the next page, next line. We have x cube root of 2x squared over 9. So you need to multiply by 2x squared, cube root of 2x squared. Twice. Because we want the exact same things 3 times. So in the denominator, we can write 4x to the 4. Really? That means I have to reduce again. So why is I even bother reducing at the beginning? Hmm? Because we reduce at the beginning. So 2x to the 5, we reduce becomes x outside and x squared inside. So we have x outside and x squared inside. So you're reducing these. So you have to multiply the same thing twice because we have 3 power. But then we end up getting reducing again. So why wasting our time? Well, I'm going to show you another method without reducing method. But for now, we have x cube root of 2x squared 3 times. On the denominator, we have 9 cube root of 4 x to the 4th. So 3 power 3 root cancel out. We have x times 2x squared. On the denominator, we have 9 cube root of 4 x to the 4th. Eliza?
How can you multiply 3 times twice?
Because what is your root? So how many times do you want to see the same thing?
Well, what if you just did it once? Wouldn't it be
We are given once. How many more you need?
because once you add the exponents, so wouldn't it be 3x squared like once and then that be 3, so it's like wouldn't it be 2x the third if you added 1 to x squared? Because you would add the exponent.
Say it again. Oh yeah, that's why we don't need x squared. We only need one more x.
Yeah, that's what I was saying.
So you can multiply by
Just one pair.
just one x is not enough, right? If you multiply
two.
with one x,
Oh no, you have to do 2 pairs anyway. To get
like we have to have the 2 3 times. We definitely need 2 more 2's, right? And we have x squared. If you want to see x cubed, then it doesn't make sense. Because you have to multiply the exact same thing. So yeah, we do get something extra here. But actually we didn't have to do that.
these 2x.
We could only multiply by one extra x and 2 plus. Let me show you another method, okay? So this is incomplete because we have to do more. Let me give up here, incomplete. Instead, let me show you one easier way, I think. Second method. Why my pen is not working today? Cube root of 2x to the 5 over 9. One easier method, okay? So ignore whatever you did. Ignore. What is our goal? To see 2 3 times, right? Because we have cube root. And we have to see x one more time so that we can divide it by 3. Right? Our goal is to have everything so that we can divide it by 3. Have the power that is divisible by 3. That's our goal, right? So we can simply add. We are given only 1 2's. So how many more 2's we need? 2 more 2's. So 2 times 2. Now 5 is not divisible by 3, but how many more you can add so that you can divide it by 3? After 5, what number is divisible by 3? 6. That means we need only one more x. So the total we have 5 plus 1, 6 of them. This is 1, not exclamation. It's 1. Right? So now we have total 2, 1, 2, 3 times. And we have x 5 plus 1, 6 times. Right? So we can write cube root of 2, 3 times. And cube root of x 6 times. Our goal is to do something, anything in multiplication so that we can get rid of the cube root. The only way you can do is having a cube power or a multiples of cube power. Now we have two ones. One is not divisible by 3. So we need extra 2 more. So total we have 1, 2, 2, 2, 3, 2. So 2 to the 3 power. We can cancel cube root with the cube power. We get 2 back. Now for variable, we have x 5 of them. Unfortunately, we cannot divide by 3. So how many more x you need so you can divide by 3? Only one more. So I have 1 more x. So now total, how many x you have? 6 of them. So cube root of x to the 6. That means we added extra cube root of 4x, right? This was extra cube root of 4x. And remember, whatever extra we have, we need to put them on the other side. So the denominator will put cube root of 4x.
And 4x, the power of 4. No.
No, we just added this extra. 2 more 2 extra and 1 more x extra. So total we have 4x extra. Right? We didn't have anything extra. Only these, the blue ones are the extra ones. But what happens to the numerator? 2, 3 of them, x 6 of them, under the cube root. As a result, cube root, cube power cancel out, and 3 goes to 6 twice. So we have 2x squared on the numerator and denominator 9 cube root of 4x, which is not reducible. Well, it's much simpler than what we did before. Let me make this smaller. If you didn't understand anything, it's fine because this will not be in the exam, but this will be in the homework. Now, who needs help? Who want me to explain it just for fun? Okay, so tell me which part was confusing.
No, I did the other part. Other
one.
Yes. So
At the end, you're supposed to get the same thing back. So if you did this, see here, 4 power is bigger than 1, 3 power. So we have to reduce the 4th power. So it's x cube and x1. The x cube will give you 1 x here. And then 1 extra x will go inside the radical. But then we have the numerator x and denominator x. They cancel out. So we have 2x squared on the top and 9 cube root of that on the bottom. Which is the same thing we have here. 2x squared and then 9 cube root of 4x.
So because I got 2x to the power of 3, 9x to the power of 1, then cube root of 4x to the power of 1.
Good. Now you have x on the top, on the bottom, cancel them.
Oh, yes.
Okay, Jannah, which part?
How'd you get to the first time?
So did you understand the idea? We want all of these to have 3 power or multiples of 3 power. Now 2 has what power? 1. But we want to have 3 power.
Oh.
That means how many more 2's we need to multiply? 2 more. So 2 power here, 1 power here, total we have 3 power. Same thing for x. We have 5 power, but 5 is not divisible by 3. So we need 1 more, so we have x to the 6, which is divisible by 3, we get 2. So the numerator doesn't have any more radical. We have 2 single, x squared single, and whatever we needed extra, that goes on the denominator under the radical. And then we cannot simplify anything, so we stop. Okay? So whatever method is easier for you, remember. But this method is actually fun. You just need how many more you need. You put them. And then extra, see here in the previous one, there are so many extra things. Looks complicated, but this looks much cleaner. I like this method. Anyway, so you don't need them for the exam, but you do need to know how do you rationalize one term and how do you rationalize 2 terms. And now solving radical equation, there will be one question here in the final exam. No. So this is 10.5, we are done in 10.5, and now you're doing 10.6. 10.6 talks about solving radical equation. And in radical equation, there are two things you must remember. One thing is you have to have radical term alone in one side before you go for any method. Okay? So when you have radical, when radical has anything at the beginning, at the left side or on the right side, it's very strong. You cannot touch it. So in order to get rid of the radical, we have to get it alone first. So it's like all those left side thing and right thing, they're like bodyguards. So if you want to kill the main person, is to get rid of the bodyguards first. For example, if you have, let's say, 2x minus 1 plus 3 equals 5, you cannot do anything here until you get rid of this bodyguard. So you subtract 3 from both sides. Okay. So in order to get rid of the radical, it has to be alone. And the second thing you have to remember is that once you solve the radical, you must always substitute in the original function to see if the left side gives you the same right side. Because not always you're going to get the same left and right side. So if the absolute doesn't give you left side equals right side, those are called extraneous solution. It cannot have them. Just like the rational equation we have. Rational, right? When you solve rational equation, you get probably 2 or 3 answers. But when you substitute all of them back, some of them make the denominator 0, so you cannot have them. Same scenario here. If you substitute something and you get something invalid, it cannot have them. So 2 things. Before you solve anything, first get it alone. And then once you solve, must check the answer. Now let's do some example. Man, don't do this, please. Let me do the right side. The left side, just an example, you can do it by yourself. The right side, we have negative square root of 20x plus 8 equals negative 2. Our goal is to get the x inside the radical alone, solving for us. So our radical term here is this one. Our main concern or main goal is to get this alone first. Why? Because once it's alone, then we can apply the square power on both sides of the equal sign. So we get square root and square power cancel out. But we cannot apply the square power until the square root is alone. That's why first make it alone. So which one we get rid of first? The negative symbol or the plus 8? Good job. So what do you do? Minus 8. Minus 8, minus 8. We get negative square root of 20x equals what? Negative 10. Then what do we do? Square. But before square, let's get rid of the negative sign. Negative, negative. So we have positive 20x equals positive 10. And now we have 20x under the radical. We wanted it to be alone, so we got it alone. So we go ahead and apply the square power. Square root, square power cancel out. We get 20x. All right. to get the epsilon, divide by 20. Now 0, 0 cancel out. 2 goes to 10, 5. So x equals 5. But we cannot stop because we have square root. Anytime we have even root, you must check. For odd root, usually they work, so you don't have to check. But for even root, you have to check always. So we go back to the original question. Negative 20 times 5 plus 8. We want the answer to be negative 2. So negative 100 plus 8. What is square root of 100? 10. So negative 10 plus 8. Negative 2. See, we required to have negative 2 and we got negative 2. That means yes, this answer is valid. If the two numbers don't match, it will be invalid, so you don't have no solution. Okay? So two things to remember. Get the radical term alone, and then at the end, check. So go ahead. Actually, let's do one more together. So one of these will be in the final. Square root of 2x minus 1 is subtracting x. That should give us negative 2. So a radical term here is this. We want this to be alone. What do? We want it to be alone. So what we don't want next to that. So what do? If you add 2, the 2 will be even closer to that. Add x, not 2. You don't want the x, the bodyguard next to that. So add x to both sides of the equal sign. So you get 2x minus 1 alone on one side, and the other side is x minus 2. And now you're happy. No more bodyguard. So you get a gun and shoot it with the square power. But you cannot shoot only one side, you have to shoot both sides. So problem solved. No more radical. We get 2x minus 1. But then we face another problem. See, our life is full of problems. One problem gets solved, we get another problem. And then we solve that, we get another problem. Like, did you ever notice your life? Like, it's full of dramas. It doesn't matter how low you want to live your life, you cannot avoid some dramas. It's always full of dramas. So how do you solve this drama? Do you just distribute the power? You cannot distribute the power, so you have to use FOIL. X minus 2 times x minus 2. The power rule applies only in multiplication and division. For example, if you have xy over z to the power n, then you can distribute the power. So in multiplication and division, you can distribute the power. But if you have addition and subtraction, you cannot distribute the power. You have to use FOIL to FOIL them out. So multiply this, that, and then it's supposed to get x squared minus 4x minus 4. Right? X squared minus 2 squared plus 4. Thank you. And then twice their product. So 2 times 2x, 4x. Yep. So we solved the radical problem, we solved the power problem, and now we have another problem. we have x all over the places. So it is our next step. Not 4x, like bring everything to one side so that you can see 0 on one side. See, now we are solving for x, so you have to see 0 on one side because our highest degree is 2. For degree 1, we didn't have to bring everything to one side because we simply divide one side. But here we have degree 2. For degree 2, that means you have to use either factoring or quadratic formula. That means we have to see 0. So another drama, we solve it by subtracting 2x and adding 1. So left side becomes 0. And right side becomes what? X squared minus 6x plus 5. And now we like it. It's a simple quadratic equation, which is factorable. Can you think of two numbers? Multiply to 5, combine to 6. Multiply to 5. 5 and 1. So 5 and 1. Both of them have to be negative. You have to get negative 6. So you're distributing 5, not 6, okay? So one of them has to be 5, another one has to be 1. 5 has to be negative because this is the middle symbol. The middle symbol always goes to the bigger one. So now we are very close to solving. What do you think our next step is? Set each of them separately equals 0. So x minus 5 equals 0. X minus 1 equals 0. That gives us x equals and positive 1. And now we think, oh, all the dramas have been solved, so we can relax, right? But guess what? Can you relax? We have to check it. A new drama. Check.
If we don't check it,
You get 0. Because not always two of them works. Sometimes both of them work. Sometimes none of them work. Okay?
this is what.
That's what you have to check. Since you wasted all this time, and if you don't check, all the time you used to solve will be wasted. So would you like to waste your time or spend a little bit more time to solve it completely? And when you check, you must use the original one. Okay, either the original one or the second line. But the original one is better. You definitely cannot use anything that doesn't have a radical. You have to use the radical equation, okay? Because your goal is to check the radical. So you have to use either first line or second line, one of them. But definitely cannot use anything after the second line. Minus 2 times minus 2. So x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. So it's called FOIL, not distribute, FOIL. So it means you take one part from one binomial and then another part from the same binomial and multiply them individually. Okay, this is same as x times x minus 2 and then minus 2 times x minus 2. And now multiply them. Now distribute them. You get this. And actually noticing the exam, a few of you didn't use FOIL, it just multiplied x with the x, 2 with the 2. I mean, in the question, whatever you have, which is wrong because when you have 2 by 2, is supposed to get 4 results, 4 things, not 2 things. Okay, anyway, so our question was 2x minus 1 minus x should give us negative 2. So answer has to be negative 2. The first one, let's say x is 5. So 2 times 5 minus 1 minus 5. What do you get inside? 9 minus 5. What is square root of 9? What is 3 minus 5? Negative 2. Do we have what we wanted? So we're going to accept 5 as an answer. Now let's check the other one. 2x minus 1 minus x, answer is negative 2. So 2 times 1 minus 1 under the radical, we're subtracting 1. Now this time, what do you have inside? 2 minus 1. What is square root of 1? Square root of 1? 1. And what is 1 minus 1? Do we have the same thing we wanted? So see, this doesn't work. So even though we get 2 solutions, but only one works, the other doesn't work. Not always. Sometimes both work. Sometimes none of them work. If none of them work, our answer is no solution. That's why you have to check. Because in the final exam, it will be multiple choice. And then if you, without checking your answer, if you see both of them, then circle that, your answer is wrong. And if you get over smart and do no math, just replace all those choices on the question and then see which one is the correct, you get 0. Because the direction says solve for x, not check your x. So don't get over smart, okay? You must show the work and then check. Don't only check the choices you're given. Okay, I have 1, 2, 3, 4. 2 of them is fine. Try these 2. What time is it? 23. So we can finish this one. And then we'll start 10.7. We can finish 10.7 tomorrow. And then we have 1, 2, 3. 3 days for chapter 11. And remember, all the homework and quizzes, you can submit them till 11, August 11. After that, you cannot submit anything. So whatever you missed so far, even though you said the deadline is over, but you can still go back and then change them. Diana here, Martin here, Christopher here, Axel here, Matthias here, Eliza here, Angel here, Hunter here, Maria here, Ashley. I didn't see Ashley today. Exona here, Justin here, Kathy here, Asim here. Kayla, she's not here today. Rachel here, Calicia's here, Maria here. Jannah here, Jasim here, Jonathan absent. 1, 2, 3 absent. What? I think a little. Check 6. How about the 2? Or whatever doesn't work, just cross out the side of the line. And then that's right.
Yes. X minus 4, so the x minus 4 squared.
And then minus 4.
And now we'll forgot that.
So write this over here and then we'll change so we're going to try.
Oh, yeah, I thought you were leaving.
We don't have minus.
No, yes.
So what are you push? Where do I use that to write it? No, let's say not to. No, this minus 6. How can you?
I don't know. For this.
Finally. Where? It's where? Where do you look at? What did you tell you to take that in your butt? What's the first thing you do? No. Okay, so you have to make the radical alone. Okay, so did you get your syllabus? This, right? It cannot solve. So what we need is only very accent. So two things. Two things to your first thing is get the result alone before you do any step. Second one, after you solve. And then it's gonna find your get it? Minus 3x minus 3x. How do you get minus? We have 3 and 3. Do you see 19 years? And then you just combine like a term for the other sides. Question 4.
Wait. No, wait, they're wrong. Okay.
This is a question. That's
I can go down to
No. So one square, you have two pieces inside of the left side. Whatever you left side, so you left side. Your
Yeah, they're 3x minus 8.
no, they're both negative. They're both negative.
Oh my god.
Okay, let's do them together. On the left side, we get lucky. We have the radical type alone. So we can go ahead and square both sides to kill our radical. Square root, square power, cancel out. We get 2x minus 3. And then here we have to do FOIL. X minus 3 times x minus 3. If you don't know how to FOIL, I would suggest to do this. Take first element and multiply the entire thing. So x times x minus 3. And then take the second element and multiply the entire thing. Oh, did you notice purple and yellow makes red? Wow. So negative 3 times x minus 3. So here to just do monomial and binomial multiplication, you have x squared minus 3x. Here we have minus 3x with a plus 9. And here, common mistake, what many of you wrote, negative 3x minus 3x is? You guys told me it's 9x. See, 0 or 9x, both of them are wrong. You have the same symbol, so you add them. 3 and 3 supposed to be 6x with the same sign. So it's x squared minus 6x plus 9. X squared minus 6x plus 9. And now since you have a square and so many x's, so you need to bring everything to one side so that we can factor. So 0 equals x squared minus 8x plus 12. And we got lucky again. This is factorable. Which two numbers multiplied to 12 combined to 8? Negative 6, negative 2. So x minus 6, 0 gives us x is 6. X minus 2, 0 gives us x is 2. But if you see them on the multiple choice and then check without checking your work, you'll get wrong. So you must check your work. 2x minus t under the radical supposed to give you x minus 3. In the first one, your x is 6. In the second one, your x is 2. So 2 times 6 minus 3 and 6 minus 3. 2 times 6 is 12. 12 minus 3 is 9. So we have square root of 9. 3. And what is square root of 9? 3. So both left side and right side gives us 3. So x equals 6 definitely is correct answer. Now on the other side, we have 2 times 2 minus 3 under the radical and 2 minus 3. So we have 4 minus 3, which is 1, square root of 1, negative 1. Now if you don't have any variable, your radical cannot ever give you any negative answer. So square root of 1 is not negative 1. It's positive 1 because this 1 doesn't have any radical. In other words, you are not solving for x. When you solve for x, then square root of 1 could be positive 1 or negative 1. But you are not solving for x, you are checking your x. So square root of 1 has to be positive 1. But they are telling us that positive 1 and negative 1 are the same number, are the same. So you cannot accept 2. So our only answer that is acceptable is x equals 6. Same thing, the other one is subtract 4 from both sides. So 3x minus 8 and x minus 4. Square both sides. We get 3x minus 8 equals x squared minus 8x plus 16. We subtract 3x and add 8. So we have 0. And on the other side, here, x squared minus 11x plus 24. Two numbers multiplied to 24 combined to 11. Negative 8, negative 3. X minus 8, 0 gives x equals 8. X minus 3, 0 gives x equals 3. And when you check which one works, both of them or only one of them? Which one? 8 works, 3 doesn't. So check. I don't have time to check, so you check. Okay. One of them definitely will be in the final exam. And obviously will be in the in-class exam. So from this section, I'm already telling you there will be one question from here and 2 questions from the rationalizing. Now, not always you're going to see square root. Sometimes you may see cube root. But it doesn't matter what type of radical you see, the method stays same. The first thing is to get the radical alone, and the second, check your work if especially you have an even root. For example, here you have cube root, so if you don't check your work, it's fine. But for even root, you must check. So here you have two choices, either subtract 4, or you can just simply add the radical thingy. So let me add the radical, it will make our life easier. Add the cube root of x minus 8 to both sides so they cancel out. So 4 equals cube root of x minus 8. So you're happy, we have our radical on one side. What do we do next? Cube root is given. Cube power to the third power. So we need the cube power this time. Because the cube root only cancel the cube power. So it's 3 power, not 2 power anymore. 3 root means 3 powers. So what is 4 times 4 times 4? 64. X minus 8. We don't have to bring everything to one side because our x is only x. So instead, what do we do? Plus 8. So x equals 72. Since it's cube root, you don't have to check, but it doesn't harm if you want to check. If you do check, it's 4 minus cube root of x minus 8. Then 31 is 0. So 4 minus cube root of 72 minus 8. What is 72 minus 8? 64. And what is cube root of 64? 4. And 4 minus 4, which is exact same thing. So we did get the right answer. So for cube root, apply cube power. For fourth root, apply fourth power. For square root, apply square power. So whatever radical is given, you have to apply that power, not a different power. If you apply square power here, you're doomed, okay? You cannot solve it. And then we have another scenario. What if we have radical on both sides? Well, if you have radical on both sides, your life is easy actually. All you have to do is what? Square both sides. So we get 8x minus 3 equals 3 minus 8x. You can bring the x's together. So you can add the 8x. So you get 16x minus 3 equals 3. What do you think we should do next? You can bring the 3 from the right to the left or left to the right. Bringing left to the right will be preferable because our x is only 1 power. So 16x equals 6. Lastly, we divide by 16. Huh? 3/8. That reminds me of something. Okay. So 16 and 6. Can I cancel 6 and 6 here? And the answer is 1. Does it make sense? No, right? If you know this doesn't make sense, then if you tell me, if you have, let's say 2x minus 1, and then let's say x squared plus 5x minus 6, something like that. If you tell me that, now let me say this is 4, okay? Let's say this is 4x, this is 2x, let's say this is 3, okay. Let me write it again. X squared plus 4x minus 3 over x squared plus 2x minus 6. You know that this doesn't make sense. All of you know, right? This doesn't make sense. Then how can you tell me that you can cancel this, and the answer is 4 minus 3 and 2 minus 6. So what? 1 over 4? How can this make sense? You know that just because you see something on the top and bottom, you cannot cancel them. Then just because you see x squared on the top, x squared on the bottom, how can you cancel them? This and this, they're exact same thing. 6 and 6 doesn't make sense because this is not 6, this is 16. Even though it has a 6, but you cannot cancel them. Same thing here. This is not only x squared, it's x squared with something. So it's one whole thing. And the denominator has one whole thing. How can you cancel them just because they look same? It doesn't matter. If 16 is one number. It has two elements but one number, right? 16. Same thing here. X squared plus 4x minus 6. It's one polynomial, one family. Only in where? You can cancel the variable only in which case? In multiplication and division. Only in division. Do you have a division? Only division here? No. You have one polynomial divided by one polynomial. So it's not multiplication, not division. It's one polynomial divided by one polynomial. So just because you see the same thing, it doesn't mean they're cancelable, okay? You have to factor. Then when you have a multiplication, then you can cancel. In addition, subtraction, you can never cancel. So please try to remember that, because when I saw that in your exam, I was like, really? Is this what I taught you in class? You see x squared, cancel them. You see x, cancel them. And leftover is your answer. Like, I really want to see what is going on inside your brain. Okay. What time is it? 48? So tomorrow we are going to do 10.7, which is basically whatever we have learned today with negative 100 the square root.
In that day, just curious, you cancel a 42, like, we simplify the 42.
You cannot cancel anything here until it's factorable. If it's factorable, then you can cancel factors. But here, there's no way to cancel anything. Cancellation is not possible. You cannot cancel anything. The big F, you cannot cancel anything. You have to cancel in factor. And if factors are cancelable, then you can cancel the factor. So have a good day, everyone. See you tomorrow.